My name is Jeff Gable. I think by now I've had a face-to-face conversation with almost everyone in this room. If I haven't, please come find me afterwards. What I do, I'm an embedded software consultant. I help companies develop embedded software for safety-critical applications like medical devices. I've also done some work for aerospace and automotive. And the topic of my talk today is continuous integration. This is a software development practice that's kind of taken the web development world by storm. And I want to evangelize it and bring it to medical device software development because I think it can help us a lot. So putting medical devices to the side for a second, so let's talk about traditional IT organizations that would make web applications for their internal business processes, circa 2005. You have lots of engineers working on different features. You have these development branches running in parallel. Merging them together is very, very painful, so people avoid it. So they keep going longer, and it gets more and more painful. There was very much a throw-it-over-the-wall attitude from the software developers to the IT operations people. And so you would often get, marketing has set a deadline for this application to be released on Monday, and it gets thrown to the IT operations people at 5 p.m. on a Friday, and have fun deploying this over the weekend. And there was a lot of manual, error-prone development, probably poorly written instructions, and people really didn't have very much of a process for how to get applications to deployment. And that results in what you would think it would, which is very low-quality software, and the iteration time was measured in months. A lot of these applications are on a release schedule. Every 9 months, we come out with a new version of the software. And so that means if someone in marketing or on the business side has an idea that they want to test with the customer, they have to wait months and months to get an answer. And I know that, is Arlen? Yeah, there's Arlen in the back, was talking yesterday about getting answers, and that's what he wanted to do with this simulation, is get answers faster on the technical side, and certainly on the business side. If you have a hypothesis you want to test with the customer, you want to get answers quickly, and this very, very slow, high latency software development process just kills that effort. It slows you down. So there are a lot of people who have done work in the manufacturing industry on speeding up the manufacturing process and reducing the latency of the manufacturing process. You can respond to the market needs more quickly. You may have, especially if there are any MBAs in the room, you may have heard of these kind of books. So there's the Toyota Way. Toyota was a company that really espoused lean manufacturing methods, kind of developed a lot of groundbreaking efforts. There was the theory of constraints. So these principles from lean manufacturing have been applied to great effect in the manufacturing world to increase the responsiveness of the manufacturing process to the market. And some very smart people looked at that and said, hey, why don't we start applying this to software development? So this revolution that came out, you may have heard of the term DevOps. So that's development and operations smashed together. And that's where, like I've heard a lot over the course of this conference, breaking down silos, trying to get people to work together, regulatory and development, and that's part of one of the tenets of systems engineering, Martin, is getting these different stakeholders in the room and having them all contribute to the process. And that's the core of this DevOps revolution that, again, has taken the web development world by storm. And there's 3 principles that came out of this. One is to apply systems level thinking, and the system I'm talking about is the business system. So again, you have ideas that you want for the business that you want to test in the marketplace, and you want to reduce the amount of time that it takes for that idea to actually get in front of a customer so that you can validate that hypothesis. Second is to improve the feedback loops. So again, getting it to the customer so you can test that hypothesis and getting that feedback back up to the business, but also at various stages in the process, if there are any defects that are passed downstream, you want them immediately to flow back upstream that information to fix the process and not allow this to continue. And then to foster a culture of continuous improvement. And this last one is doing things like prioritizing the flow of daily work almost as much as the daily work. So a lot of people think, we're too busy, we're late on our projects, we're behind, we don't have time to invest in making our process better. And there's some good rules of thumb that, at least in the software world, that you invest 20% of your effort every development cycle to improving your process. So that's kind of a good metric to follow. That way, 80% of your time is actually still getting work done. So you're not, completely ignoring that, but every development cycle, you're investing 20% of your effort into improving your process. So that all sounds very kind of theoretical and high level, so let's get really concrete. So at least from the software development and operations side, when a software developer has written code for some feature and they commit it to version control, there are then a whole lot of steps that have to happen before that's actually deployed to the customer. You have, IT may need to provision a server. They need to install a bunch of software packages. They need to configure the network settings, whatever it is. There's need to be unit tests. There need to be acceptance tests. It needs to go to staging maybe for a little while for testing and then go to the production servers. So there's all of these different steps that go there. And again, back in the day, most of them were manual and error prone. And basically what people are starting to do is just automate that, all of it. And it's really, really surprising how much of that you can automate. Particularly, you would think something like provisioning a server is hard to automate. Well, nowadays there are software tools that people have developed as part of this effort where you describe your infrastructure as code. You have human readable text configuration files that say, I want this server and I want it to have these libraries and they better have this minimum version or what have you. And nowadays, this with all the servers being in the cloud, you almost can't not do it that way. And these configuration files that describe your infrastructure, again, they're stored in version control with your application code. So you really can't say, I have an application and there's some dependencies that if they're not there, the application doesn't run right. So I'm not gonna, I'm gonna have some written instructions down. No, those should actually be stored in text right along with the source files for code. And what this gives you is repeatable, guaranteed deployments of applications. And as a result, what you get is high quality software. And if you can automate all this, your iteration time can be measured in hours. And this is actually real. So if you look at, again, going back a few years to a typical enterprise, you would have this deployment frequency of every 9 months, you would get a new version of software. And if there was an urgent business need to go through all of those manual steps, again, was months. And because you had this very slow feedback time, you had low quality, low responsiveness, low reliability. You couldn't get fixes to the application if you discovered them in the field. And this chart is from a book I'll show you later called The Phoenix Project, but this was, I think, 2012. Amazon was doing 23,000 deployments a day. So what that really means is that each deployment is extremely small. I see a bug, I fix it, I kick off this process, and a few minutes later, it's done, it's live, it's going to users. Now, in order to do that, you have to have really, really solid testing, but that's part of your responsibility as engineers, is to make sure that all the testing that you would do to do your due diligence, to make sure that your code is okay to go in front of customers, that all of that is built into this automated process. And you can imagine what that does for the business in terms of enabling new experiments to be run, and you can have a marketing person come up with an idea and you can have code in front of customers the very next day, testing that out to see if it works. So it really changes the business side of things, speeding up this software deployment so quickly. And it's now the industry standard in web development. If you're developing a web application and you're not doing this, you're way behind the times, and you're going to go out of business because you can't keep up. So I'm on a bit of a mission to take these lessons and apply them to software development for medical devices. So real quick, I think I'm the only software engineer in here who works on a medical device that has software. Yay, oh good. I was afraid no one was going to raise their hands. Okay. So who is actually responsible in some way for software? Okay, so a few of you. So basically I want to evangelize how we can apply these lessons to software development for medical devices because I've very rarely seen it. So some prerequisites for this. One, your software has to be in version control. If you're not version controlling your software, you're in really big trouble and you've got bigger problems, but please come see me afterwards. All version control is not alike. There are more modern version control systems that are much less painful to work with for developers. Git is the most popular one in the world right now. It's been popularized by sites like GitHub. Maybe you've heard of them. The second prerequisite to this is that your build process, just building your executables that actually get flashed onto your device, that build process has to be fully automated. You can't be working in an IDE, an integrated development environment, where someone is with their mouse clicking build and then configuring things like that. It has to be you type in a command and it goes and does the rest. Once you have that, you can start having little robots on the internet do that for you all the time, and it's wonderful. The next thing to do is you start adding automated testing. And there's a couple of different levels of this. There's unit tests where you're testing low-level functions on your code, and you can actually run them on a host computer rather than on the target device that maybe is running a different processor with a different architecture. And I've heard a lot of people complain, essentially, no, my code runs on this device, and it's dependent on the hardware, and that's just not unit testable. To which I say, bullshit. Just want to make sure you guys got that. It can be done. It is worth the effort. And going through that exercise really forces you to have good modular software architecture. And there's another book I'll show you at the end that really walks you through how to do that. Again, I don't know that many people in this room are actually going to go through that exercise themselves, but if you hear these excuses from your software, there we go. If you hear these excuses from your software engineers, have them call me. And then there's integration tests, and these are maybe more common these days. But this is where you're running code on the actual device, and you can still apply a fair level of automation to that, especially if you build in scripting and data instrumentation capability into your embedded code. At that point, you can have something running on the host communicating with it saying, run this command, give me the data back, and you can verify it. That gets to be a little more messy in the real world because hardware sometimes fails, it's not as predictable, but it can be done. And you can do special test images of the software that have a very limited capability to exercise your hardware in a certain way. And there again, that principle that we saw before of infrastructure as code. So a lot of people, it's a very common problem in software development for different engineers saying, well, it builds on my machine, I don't know why it's not building on yours. And there again, you can create your build and development environments, you can describe them with configuration files that would say create a virtual machine that would have the compiler and the flashing tool and probably your development environment with your debugger, everything else in a virtual machine. And I've been working this way for 5 or 6 years now, where I do all of my software development in a virtual machine, and it's fast enough. It works. And at that point, you're guaranteed that everyone who's working on this project has the same development and build environment, and then you reuse that on your build server, and this automated build that takes place is using that same configuration. So this may be getting a little too in the weeds, but at least I'll give you an overview. If you're in an organization, you say, hey, that sounds great. I actually want to get started with this continuous integration special sauce. You buy a build server and you don't skimp. You make it really, really fast. Lots of RAM, lots of processor speed. There is continuous integration software out there. An open source option is called Jenkins. There's another good option called GitLab. There are several others that are paid. And the very first thing you do is just have it run your builds automatically every single time you check into version control and email you if there's a failure. All of them come with nice, pretty dashboards which show you the latest status. And then you slowly, over time, like we said, investing 20% of your effort every time into adding tests, defining more of your infrastructure, and just improving that, everything that you're capturing there. So this is the dashboard of a continuous integration build. I stole this from a person's talk on the web. But this is checking out the latest version of code, and then you have different unit tests, and you're running it with the debug configuration and the release configuration. And then you run it through your code coverage tools, and then you run it through different sanitizers. And if any one of these steps fails, it immediately stops the rest and lets you know, and your highest priority is to fix that issue and then move on so that your code is always in a working state. And you can see from, I didn't just want to throw this up and not explain it, but you can see there's a lot of things you can put in here to really do a robust check of your software and know that if you check in software and it passes all of this, and you've done your due diligence and you've done this properly, by definition, it's suitable for deployment. So at this point, I kind of have an open question for the group, and this is, I was quizzing Mike on this yesterday. So medical devices are not web applications. We are highly regulated. The FDA is an important part of the deployment chain. And so essentially an open question is how fast can you make that process? And that's if, this is all predicated on the fact that you have done your due diligence and you're comfortable, I've made a software change, I've tested it well enough, I've analyzed it well enough so that if my spouse or my child were using this medical device, I would be comfortable with this software change. At that point, only once you satisfy that condition, what's the fastest you could actually deploy it to your device? And if that involves the FDA, what are the steps you could do? It's an open question for the audience. What can you do to speed that process up?
We have any contestants? Walt?
I'm Walt McClay.
Hi, Walt.
Yeah, good to meet you again. So not all deployments require FDA approval.
That's true.
If it's a simple deployment, you can deploy it immediately.
Right.
Of course, if your device is somewhere out in the field, you have to find it and update it.
Bing, bing, ding. Yes.
Is that the answer? That's so complete. I needn't give anyone else the mic?
A little bit. So I guess there's that definition of, Christine, were you? Oh, Marin, okay.
So I'm Mara Nelson. I have done a little bit of medical device software in my past. So as Walt mentioned, there's a pretty straightforward assessment you can do on the software, even before you get to the point of deployment, to know whether you've got to bring the FDA into part of that or not. The other part of the deployment chain is the end user.
Yes.
Because if you're making a change that impacts user interface or anything like that, you may have training and other things to address. So I think it's important to keep the user as part of the deployment chain as well.
Absolutely, absolutely. And that's like I said, all of this is, I wanted to bring up the FDA part because inherent in that is the assumption that you have done all the analysis that you are doing the right thing and that you've checked all the boxes for the right reasons, not just to check boxes for compliance. And so, Walt, you mentioned updates, over-the-air updates. Nowadays, web applications actually have continuous delivery, where literally the engineer checks in code, and a few minutes later, it is deployed live to real users, maybe in a staged fashion where they're looking for problems and would automatically roll back if there were problems. But they instead of continuous integration, that's the next logical evolution, that's continuous delivery. I don't think that's feasible for medical devices. I'm not suggesting that it is. But you can certainly greatly increase the cadence, the frequency of your releases. And what can that enable? Tesla does a lot of things that I disagree with, but an example, people have seen, Tesla has kind of shown the automotive world what's possible in terms of, they just push something to your car and now your shocks ride differently, or they've solved an issue in the field, they are getting reports of a problem and a week later they have pushed a fix and it is running on everyone's cars. So again, just use that as inspiration to kind of spark your imagination for what's possible. And whether that enables you to work differently, to test business hypotheses in a different way that maybe is not feasible before. So all that requires the engineering of an over-the-air update, but it's doable and people are doing it a lot. Yes, sir.
Not waiting till the end.
Please.
I'm holding the mic so I can, Anyhow, what about legacy systems? I mean, yeah, it would be ideal to be able to change everything everywhere, but we've had a system in the field for the last 10, 15 years. Does it mean we'll just have to wait till the next generation of product?
Yeah.
Because it's just too much to reverse. And
right. Well, I mean, a lot of those have no means for updating. Some of them do, but it's, you have to ship USB sticks to your customers. So I guess what I'm advocating for is a new way of engineering new products. Yes, Christine.
Hold on.
What has already happened? Sorry.
Legacy products in the field for large device manufacturers are already receiving remote service. This is already happening. So they do it usually through the hospital IT infrastructure. Okay. They're connected to the network. There's huge issues around cybersecurity. Joe and I were present for a presentation in Washington on this topic where we had the manufacturing side and the hospital institution side. It's happening though, because these guys, especially in imaging systems, they have to get the software out there and they can't afford a service visit to deliver a USB stick, and they can't hand it to anybody else. It's already happening.
Sure. Yeah. It's just very painful. And so again, what I'm advocating, yes. So you deal with legacy systems the best that you can. And what I'm advocating is for your new products, use this process, even if you don't worry about the deployment, the increasing the cadence of release, continuous integration during the development until release speeds up that process so much because you don't have to have, it's breaking down the silos like in the web development world between development and operations. In the medical device world, it's between development and QA. So involve your QA's people creativity to automate these tests. How could we describe in computer code how you are testing this device? And let's actually code that up, and then we can automate it, and then you don't have to run the same manual test every time I do a release. It can get run automatically. So it's useful definitely during the development phase.
Just thought I'd point out that, Ryan Carpenter. And I thought I'd point out it's not only software. I'm seeing several hearing aid companies delivering firmware updates via apps.
Yeah.
I know the old way too. I worked with a product manager in Sydney for Cochlear. At the time it was shipping CDs for updating firmware and so on.
Mm-hmm.
It was a long struggle too.
Yeah, so when I say software, to me, that includes firmware, yeah.
Yeah, sure. Well, at any rate, I'm seeing that happen in a number of hearing aid manufacturers are delivering firmware updates over the air through apps usually. And in the case of legacy devices, many of the legacy devices don't have the same full capability as the most current wireless hearing aids, but they do have older wireless technologies, so some of them will use a streaming device to connect to a phone, for example.
Right. And I would say that, here, I'm going to go back one second just to the over-the-air updates. So anyone who is selling a connected medical device, so the FDA has issued guidances on post-market cybersecurity, a lot of those connected medical devices are using open source libraries. Security researchers are pounding those libraries all the time and finding new vulnerabilities. And if you don't have a list of what libraries are on your device, and you're not monitoring the central national worldwide database for new vulnerabilities, and you're not getting latest versions and then patching your device, I mean, it's the reason you get updates on your iPhone and your Android phone all the time is they're constantly finding and fixing new vulnerabilities. And people are still designing medical devices with no way to patch. And so now you have medical devices on hospital networks that are completely vulnerable. And the FDA it used to be, well, if it's on the hospital network, it's the hospital's problem. And they're starting to change their tune. So they expect you to be able to patch for security reasons.
I know this is a terrific layup for you, but let's say that they employed you as their consultant. What are you going to do about it?
I'm going to tell them to do it better. So my role is so I help people develop embedded software better. And I have two kind of sides to my consultancy. I do coaching where I help them improve their process and also help them early in the product design process flesh out their development plan. So I kind of bring the technical side to systems engineering, where actually having enough knowledge of all the different engineering areas to be able to intelligently spot problems. And then on the development side, I specialize in firmware development, in control algorithms. Not as much the cybersecurity, but I know enough to be dangerous and at least spot the problems coming.
Sounds pretty expensive. Just saying.
Yeah.
Go on, please continue.
Okay. And the last thing I wanted to do, if anyone wants to know more about this, here's some learning resources. Again, if your software engineers are giving you the excuse that they can't do unit testing on their embedded hardware, give them this book. It's wonderful. This one is a business novel kind of describing the revolution that I talked about in DevOps. Like those business novels, it's pretty cheesy, but it is a little bit easier to read than, say, this one, which is more the same information presented in a textbook form. But it really is, even not working on web applications, working on firmware, these two books were really eye-opening for me. Just let me know kind of this whole world of capability that's possible. So
there we go.